Hey, this is Lance from LangChain. This is a talk I gave yesterday at the AI Engineer World Fair, and I wanted to get on here and just kind of give it again, show all the slides, and then also show kind of a quick code walkthrough of everything I talked about. And the theme is architecting and testing reliable agents. So, LLM applications follow a control flow. You typically start the application with some kind of user input, it follows some set of steps, and it ends. A chain you can think of as just a control flow set by the developer, so it follows some set of steps that the developer determines ahead of time. An RAG chain is a good example of this. A question comes from the user, you hit a vector store, you retrieve documents related to the question, you pass them to an LLM, the LLM produces an answer which you return to the user. Now an agent you can think of in simple terms as a control flow that is actually set or gated by an LLM instead of the developer alone. So in this kind of toy example, you start your chain, you pass from step 1 to an LLM, which then reasons about, do I do step 1 again or do I move forward to step 2? So again, chain is developer-defined control flow that's fixed. An agent is just an LLM-defined control flow. Now, typically, when you talk about agents, you kind of also hear about this idea of function calling or tool calling. And really, when you think about it, how does an agent make a decision about what step to go to? So we can use tool calling to actually select a step or tool that we want to use. So here's an example. An LLM receives a natural language input. What is the output of step 2? And you pass 3 to it. We can actually bind step 2 as a tool to our LLM. And the LLM can return then the payload necessary to actually run that tool called step 2. And again, it returns the arguments, for example, from the user input. The argument of foo is going to be 3, and the name of the tool is going to be step 2. So the way to think about tool calling or function calling is basically you're giving the LLM access to some set of tools, allowing it to choose a tool to invoke, along with the payload necessary to run that tool based on the user's input. So that's really what kind of tool calling is. And a popular approach is just to run this as a for loop, so that as you give an LLM access to some set of tools, and you allow that LLM to call tools in this kind of cyclic fashion. So you take user input, the LLM decides to call a tool based on that input. The tool runs, you return the output of the tool back to the LLM, then the LLM thinks about it and says, okay, I need to run another tool. And this will continue until the LLM finally says, I don't need to run any more tool calls, I'm just going to return a response directly to the user, and then you end. So this is the classic kind of React-style agent setup that runs more or less as a for loop. And the nice thing about this is extremely flexible. So you can implement many possible control flows with this type of agent. It can run step 1 or step 2 only, 1, 2, or 2, 1. And flexible agents have a lot of promise for open-ended tasks. For example, a lot of hype last year about different projects like AutoGPT, Baby AGI, and these were kind of open-ended agents that had access to many tools and could perform kind of arbitrary control flows based upon the set of tools to solve open-ended problems. But what we saw is, and many people have reported this, mixed reliability with open-ended or flexible agents. And the problem often boils down to LLM non-determinism, and in particular, problems with tool calling. So in this particular tool example, again, this is basically passing a tool, step 2, to our agent. You can either get the wrong payload, so basically improperly format the input based upon the user's request to the tool. So in this case, the input is 3, and we pass 4, or you can call the wrong tool. So in this case, the user asks for step 2, and we call step 3. So these are some of the challenges with tool calling that have been widely reported. So if you think about it, you can kind of imagine a continuum from, on one hand, you have chains, which are not flexible, but they're very reliable. On the other hand, you have like an open-ended or like kind of React-style agent, which is very flexible. It can implement any control flow given the tools you provide, but it's less reliable. So can you have something in the middle that's both flexible and reliable? That's kind of the problem statement. And that's really the intuition for LangGraph. And I'll kind of set up in two different ways. So one part of the intuition is let the developer set parts of the control flow. Okay, so let's say I always want to start with step 1, I always want to end with step 2, and let the developer interject the LLM in certain places to make it an agent and make it flexible. So in this particular case, I want to interject and have the agent always run between steps 1 and 2. And LangGraph allows you to express this as a graph. So again, you can express your steps as graph nodes, and you can extract the connection, or potentially the conditional connection between those nodes, as an edge. And a LangGraph agent just has a few components, which is consistent with any kind of agent. In terms of memory, it has a shared state that lives across the lifetime of the agent and that any graph node can access. Tools can be called inside the nodes, so the nodes can call tools, and importantly, the nodes can modify the state. So you're passing the state along to each node, the node can call a tool, and then you can write out the output of the tool to state. And the edges can route the control flow based upon LLM decisions to whatever node you want. So in this case, we can start with node 1, we do some tool call inside node 1, the LLM then reasons about what to do next, and it decides either to go back to 1 or to proceed to 2. But of course, you're getting that control flow. You always want to start with 1. You want to reason about 1 versus 2, let the LLM make just that decision, and once you finish 2, you're going to end. So we've seen this theme quite a bit. Papers have used this for routing. So this is kind of a nice paper called Corrective RAG that does retrieval, grades the documents for relevance based upon the question, and if any documents are irrelevant, kick out and do a web search to supplement your documents with more recent results from web search, and then perform RAG based upon the mixed results. We've seen other papers use this theme in self-reflection. We've implemented this in LangGraph as well. So this is kind of a case of a longer LangGraph that uses routing at the start to take a question, route it between retrieval or web search, do retrieval, do grading, route, do web search, generate your answer based on the results of web search and your retrieval. Now we also incorporate grading of the answer relative to the documents for hallucinations, and we can also do a sanity check on the answer relative to our question. So that's kind of the overall flow that we can implement. We've done this in LangGraph. We've shown that this works locally. And another paper uses this same theme in iterative problem solving, like coding. The idea here is simply to produce a code solution, run a set of unit tests. If any unit tests fail, pass those back to the LLM and have it try again. We've also implemented this in LangGraph. This is a collaboration with Mistral. In this particular case, we generate the code solution. We do a number of unit tests. We check, for example, like imports. Do they actually work? We ran this on a bunch of questions related to LangChain expression language, and we found we can significantly improve performance relative to just naive RAG. So again, if we kind of step back, a chain is not flexible, but the most reliable. A typical React agent runs as a for loop, most flexible, but it's the least reliable. And implementing an agent in LangGraph actually kind of balances the two in a pretty nice way. It can be quite flexible, and it can be quite reliable. We've shown that in a few different examples. In particular, we've shown, in cases where you can even run we can run a relatively complex RAG flow with local models. You can run these kind of corrective RAG flows that can run very reliably all the way down to running this with local models. And you can run these kind of iterative code generation flows really well with LangGraph as well. So I want to jump over and actually show this. What I want to show is, let's try to build an agent in two different ways. Let's build an agent with both React and with LangGraph, and let's compare them directly. So I'm going to go over, I have an empty notebook, I've just done a few pip installs, I've set a few environment variables, and I can go over here, and let's build a React agent first. And let's actually show in detailed terms what I'm actually talking about here. So first I'm going to set up a few tools, right? You think about an agent. Agents very simply require some number of tools. I'm just going to reset my kernel to make sure everything's fresh here. So what I'm doing here, let's just kick this off. Cool. So I am defining a vector store. I'm indexing 4 blog posts. And there's my vector store. And here's my tool. This is going to be my retrieve documents tool. So I'm going to retrieve documents from the vector store based on the query. I'm going to have a grader tool, which is basically going to grade the documents for relevance relative to my question. I'm going to have a web search tool, and I'm going to have a final generation tool. So this tool is basically going to generate my final answer. So if you go back to my diagram, that's exactly what we show here. We're going to build an agent that has these 4 tools. So there we go. Now let's just build our assistant. So this is like kind of the core part of the agent's planning. So all I'm going to do is just copy this over. So what's happening here is I'm setting a model. So for now I'll use GPT-4o. This state we're going to see comes in a little bit later. The assistant is really simply a class that's going to run my LLM, and here's kind of the main idea here. I have my LLM, I'm binding the set of tools I just created up above, and here's my prompt. Your helpful assistant tasked with answering questions provided to a vector store. Grade them to ensure that they're relevant before answering the question. So that's really all we're instructing our agent to do. And we're done. So this is run. Now, here's where we can just set up our agent. This is just where we're setting up the connection between the components of our agent. So I'm just going to go ahead and run this. I'm actually using LangGraph to implement this React agent. And here's all that's going to go on. I have my assistant, which has the bound tools. The assistant will look at the input. It'll make a decision to call a tool. The tool will be called. That'll go back to the assistant. It'll make another decision to call a tool or not. And this little loop will continue until the assistant does not make a tool call, and then we'll end. So that follows exactly what we talked about here. It's just going to run this loop until there's no more tool calls, then we return the answer. So it's a really simple little corrective RAG agent, and we expect it to follow the flow that we talked about in our slides, where what's really going to happen is it's going to follow something like this. We want it to do the vector store retrieval, grade the documents, if any are relevant, kick out and do web search, then finish. That's really all we want it to do. So there's our agent. We built it, and we can go ahead and try to run it. So here we go. So now all I'm doing is I'm just writing a little function that'll basically wrap my agent. I'll pass in an example. It'll basically run my React agent. This React graph is my agent. I pass in my example question. Here's where I set my example question. What are the types of agent memory? So one of my blog posts was related to agents, so I can just pass this in as a question. And we can see, so here we go. That agent ran, and here's our answer. The types of agent memory include sensory memory, short-term memory, long-term memory. And here are the tool calls. It ran retrieve documents, it graded them, and it generated the answer. So this looks really good. We're happy. We have a simple React agent. We have a way to kind of log the tool calls it's using. I can also open up LangSmith here, and I can go ahead and make sure I'm in the right tenant here. Let's open up my personal project. Let's open up this. And yeah, this should be my LangGraph. This just ran, so I can even open this up. And we can even have a look at the trajectory. So we ran our retriever. That's our retrieve documents tool. We went ahead and did the grading. We generated our answer. So there we go. We've logged our tool trajectory here. And we also have the trace in LangSmith. So that's kind of step one. We have a React agent, we've run it. Now let's show a different way to do this. I'm going to build this as a custom LangGraph agent. So let's copy over a little bit more code. Let's grab this. So this is actually where I'm going to lay out a prompt. So this is going to be a prompt simply for my RAG chain. So it's just a RAG prompt right here. And here is just where I'm going to set up the grader. So I'm going to set up a really simple little retrieval grader right here. And I'm going to use the same logic we showed above. I'm setting up this up slightly differently, and you'll see why in a minute. So there we go. Now here's where I'm going to lay out my graph slightly differently. Let's copy this over. Nice. Run this. So here's how I'm going to set my graph up more explicitly as a custom LangGraph agent. So remember, recall above with React, all we are doing is cycling between two nodes. Basically, we can actually go up and look at the diagram here. So we had an assistant. The assistant makes a tool call, and we go down, we call the tool, we return the tool call to the assistant, and this goes back and forth. Now this relies, if you go back to our slides, this relies very heavily on high-quality tool calling. So this piece. So again, a simple React agent, because we've just bound some number of tools, the tool calls need to be accurate, and the agent needs to make the right decision about what tool to call at each loop. Okay. Now with this custom agent, it's a little bit different. If you go down here, the sequence of calls is enumerated much more explicitly. I'm always going to retrieve, then I'm going to grade. Based on the grade, I'm either going to do web search or generate directly, and I'll pass whatever codes from web search into generate. So you can see I'm laying out the control flow more explicitly as a user. I'm still letting the LLM make a decision at this kind of branch point or edge based upon their grading. So that's a subtle but important distinction that we're gonna see between the React agent and our custom agent. So I've gone ahead and set my agent up here, and let's go all the way down and let's go ahead and see it running. So here we go. We'll kick that off just like before. What are the types of agent memory? And hopefully we don't see too much of a difference in terms of the outputs. Okay, so here we go. This is the output. So again, we get a sane response, and we can see our steps logged here. It goes to retrieve documents, grade them. It looks like it runs a web search because at least one of the documents was irrelevant, and we get a generate answer. So that's cool. So now we have two different agents. We set up a custom LangGraph agent. We set up a React agent. Now what I'm going to do is I'm going to show you the difference in reliability between these two. And for this, I'm going to do some very simple evaluation. I'm going to show you how to do this exactly. And we have a number of cookbooks available, which I ran through at the workshop as well, that'll show you how to do this kind of testing yourself. So first, I'm going to do something really simple. First, I'm going to build a data set of question-answer pairs that are related to my agent. So what I want to do is I want to test the ability for the agent to retrieve from my vector store and answer questions about my vector store, as well as answer questions just about current events. So this corrective agent should have the ability to first check the vector store. If any of those are irrelevant, kick back and do web search. So two of my questions are just current events questions, NBA Finals, NFL Draft. 3 are related to my vector store. I'm going to create and save this as a new data set called corrective rag agent QA. Now I'm going to evaluate the answers that come from each agent. So this is basically using an LLM as grader, and you can we have a bunch of videos talking about this explicitly, so you can kind of dig into those. But here's what I'm also going to do. I'm also going to grade the reasoning. So basically, these are the trajectories I expect my agent to take: retrieve documents, grade, search, generate, or just retrieve, grade, and generate. And I can basically just check, do the agents follow these expected trajectories of tool calling? So that's it. I've set all those up. And now what I can do is I can run my evaluation right here, and I can go ahead and kick that off. Great. So those evaluations both ran. Now I can see something really interesting right away. So let's just kind of back up. What did I do? I have a little eval set I set up here with 5 questions, inputs and outputs, right? 2 are about current events, 3 are about my vector store. And I tested both the React agent and our custom agent with GPT-4o against this little data set. I measured 2 things. I measured, are the responses accurate? So that's this answer versus reference score. And I measured the tool calls. Are the tool calls in the exact order we expect? So the second is like a measurement of like the reasoning trace of the agent. And the first is the measurement of like the output or like the end-to-end performance of the agent. So if you go back and you can see something pretty interesting if you look here. So basically I just really simply logged, you can see in my evaluation function here, I just logged the tool calls. Now let's look at React. We can see here's something kind of interesting. Now a few of these look completely fine. It'll retrieve the documents, grade them, generate an answer. That's totally fine. And 1 or 2, it retrieves, web search, generates an answer, no problem. But look at this. Some of these other cases we retrieve, then we jump right to web search, we forget to grade. Again, retrieve, jump to web search, forget to grade and generate, right? So you can see there's kind of variability in the reasoning trace of our agent with React. If you look at our custom agent, it's crisp. Every single time it follows the same trajectory. Now if we pull all the way back, let's go back to original slides here. What is the intuition here? The intuition is that, if I kind of look at the comparison here, the tool calling React agent can follow an open-ended progression of tool calls given what's bound to it. So it can set any control flow it wants given our tools. It makes it flexible, can be good for solving hard and open-ended problems, but if you want something very reliable and crisp and deterministic in production, that can be a bad thing. In contrast, kind of a LangGraph custom agent allows you to set the control flow in a very specific way, and that's what we see playing out right here. So the control flow always follows the pattern that we want. Now, of course, I understand this is going to be less flexible if you have a really open-ended use case. you need the agent to produce, arbitrary kind of, or like, complex reasoning traces or arbitrary reasoning traces, this might be a bad thing. But for a lot of kind of production applications where the control flow can kind of be enumerated ahead of time, this is actually a significant benefit in terms of productionization and reliability. So if we go and look at the scoring, we can actually see the differences here. Our React agent scores 80%. Our custom agent scores 87% in the end-to-end performance. And again, this is using the same LLM, same vector store, same set of tools, just a different configuration of those tools. And in terms of tool calling, as we saw before, 87% for our React agent and 100% for the tool calling agent. So again, more reliability in terms of the kind of controlled flow that's enacted or the reasoning trace enacted by the agent, and better end-to-end performance using custom agent versus React. So this is just kind of the highlight of what we talked through at the workshop, and gives you some intuition as to why building agents using LangGraph can be a very nice way to balance between flexibility and reliability. And the ability to lay out control flows kind of that combine the best of both worlds. So I can combine a lot of what the user wants in terms of reliability, and like I want to be able to set a path that I want my agent to take and roughly guardrail it, but allowing for some variability or flexibility. So for example, I want to inject specific places in my control flow. I want the LLM to make different decisions. And that's exactly what we show in our particular case of corrective RAG, where I do want the agent to have the ability to kind of reason about, oh, if my retrieval is bad, I want to kick out and do web search. And that's exactly what we see here, where the agent is able to correct a number of cases or produce correct responses to a number of cases where the answer and question and answer are just current events, not related to my vector store. So that's kind of an overview of what the workshop discussed. And hopefully it shows just like a nice demonstration of the differences between different kind of cognitive architectures for agents, building a custom agent in LangGraph versus a classical kind of open-ended React agent, and highlights some of the differences between the two ways of approaching the problem. Thanks.